This video will show you how to draw fats, triglyceride, phospholipid, and steroid. So the first one, triglyceride, consists of 1 glycerol and 3 fatty acids. Let's start with the fatty acid first. This consists of a carboxyl group. The carboxyl group is C double bond O, O, H, and then a long chain of carbon. So like C, 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 etc. Well, I'm not going to draw all the hydrogen now, but and then sometimes people would draw a shortcut, and instead of draw a long chain of carbon, I can just draw the condensed structure like that. That means that there's a carbon here, here, here. So 1 fatty acid, 2 fatty acid. Now we got the 3rd fatty acid with the carboxyl head and a long tail chain. Alright, what does a glycerol look like? A glycerol have 3 carbons, so I'm going to draw. And these 3 carbons are going to be connected to 3 OH group. And then obviously the rest you can just fill it with hydrogen. Now when glycerol and 3 fatty acid combine together, they're going to become glycerol. The reaction that is used to combine these things is called condensation, which that means is that you're going to take this OH and this H over here and condense that and make a water. Another name for condensation reaction is esterification. So I can just erase this HOH and make that into a bond, okay? So 1 bond. I can erase another HOH to make another bond, and that will provide me with 1 more water. 2 water, 2nd bond, 3 bond, 3 water. So condensation is going to give you 3 water. I can redraw the complete molecule over here. A triglyceride. Tri means 3. 1, 2, 3. Glycer, similar to glycerol, and then ride. The second molecule I'm going to draw is a derivative of the triglyceride. Is the phospholipid. So similar to glyceride, I'm going to have a glycerol with 3C. And then instead of having 3 fatty acids like up here, I'm only going to have 2 fatty acids. Again, every time you have a link, just remember that there's a link, an O in between this, the link. C double bond O, the tail, there's an oxygen, C double bond O, and then a tail. So only 2 fatty acids. The 2 fatty acid, this is also known as the non-polar tail because fat is insoluble. Then phospholipid, what's unique about it is that it's going to have something called a polar head. And this polar head, the reason it's polar is because it have a charge group N plus connected to 2 carbon, and this N is going to connect to 3 methyl group, 3 CH3 group. And then the reason phospholipid got its name of phospho is because it's also going to have a phosphate group in between. Now just remember, whenever you have connection of something, there's an oxygen to connect it. So this P phosphate, O4, 4 oxygen. And this phospholipids, which is a derivative of triglyceride, because it is both have a nonpolar tail and a polar head, is going to use to be make cell membrane. The last molecule we are going to talk about is steroid. Now you don't have to learn how to draw steroids, but you need to be able to recognize it, and it's fairly simple. All you have to do is just go to data booklet section 34. There's a cholesterol there, and cholesterol is a type of steroid. Pretty much all you have to know about steroid is that it got 4 rings stick together So as long as you see this 4 ring, you know it's a steroid. So for example, if you look at estrogen or progesterone or testosterone, all these sex hormones, look, they all have these 4 rings. So needless to say, steroids are usually hormones. That's it.